Yeah, so my name is Lauren Pena. I am a chemical engineer, and that's why I'm here today. Is I'm here to talk about my engineering background and a little bit about me, and how I got to where I am and how I ended up on the engineering career path. Yeah, so I have had the privilege of living a lot of places. So I grew up. Well, I was born in Greeley, Colorado. Okay, so I'm originally a Colorado native. And then I grew up in St. Paul, Minnesota, the Twin Cities, which is the capital of Minnesota. And I lived there for many years. And then my family decided to go back to Colorado. So I actually graduated high school in Windsor, Colorado. And then my family moved back to Minnesota. And so I went back and finished up college in Minnesota. I went to the University of Minnesota, the Duluth campus, which is about an hour, 2 hours or so south of Canada, right on Lake Superior, where the point comes in to Minnesota. So that's where I finished college, and then I worked after I graduated. I worked in Minnesota for a couple of years, and then I took a job in Georgia and South Carolina. Was there for a number of years, and then I've been here in New Mexico for just about a year. So I've been a lot of places. I would say Minnesota's home, and probably New Mexico's second closest. It's kind of interesting looking back because I was a terrible student in high school. Like barely any student who's listening to this, like you can overcome it. Okay, it does get better. So I finished high school with just barely above a 2.0 GPA and didn't get into college anywhere when I first applied. So it's interesting in the fact that like what I did in high school definitely impacted my trajectory many years down the road, but I would have never have thought that it would have done that at the time. So in high school, I really had no direction. I really had no plan for what I wanted to be when I finished. I was just going through the motions of like, well, I need to graduate high school. So I was actually pretty into music at the time. I really didn't take any science classes or anything like that. And I ended up taking chemistry because I had to graduate, and I failed it the first time. And then I got the privilege of taking it again and scraped by just by the skin of my teeth kind of style. I actually didn't even make it through like I think what we consider in college algebra. I didn't even make it to that point of math when I was in high school. The thing that I did enjoy was coding. I took a number of coding classes in C++ and VBA. And again, those were two classes, the computer science, I never thought would really impact me at the time. And later on down the road, I used them a lot. So uh, fast forward a couple of years, like I said, I wasn't a great student, was barely graduated, and I ended up at a community college, and I needed a lab credit, right? You have to graduate with a lab credit. That's how it works. And so I was looking at the list of classes that I could take that gave me lab credits, and I thought to myself, well, I already took chemistry twice. I might as well take chemistry one in college because I've seen it twice. Like I'm hedging to my bets a little bit. It'll be easier now because I've seen it. I ended up taking it and ended up liking it at the college level. It was much more interesting to me, like the application and the scope, and also the kind of educational freedom of it. Like, well, here's what you need to learn. Go ahead and learn it. And if you don't pass the test, that's on you. So that kind of freedom and that level of interest in chemistry at that time in my life, I was like, wow, chemistry is pretty interesting. And I was like, well, I guess I'll be a chemist. So after that terrible path through chemistry in high school, I was like, okay, this makes sense. I'll do chemistry. And so, like I said, I was at community college and I was taking my classes, and I had a friend, a really good friend at the time, and I told him I wanted to be a chemist, and he was like, no, man, you should be a chemical engineer. And that was the first time I had ever in my life heard the words chemical engineer. I didn't even know that was an option. And I completely ignored it. I had no idea. I was like, I'm going to do chemistry. That's what I'm going to do. And I kept taking some computer science classes through college, and so ultimately it came time for me to apply to a 4-year university. And I had been told, because without acknowledging it consciously, subconsciously, that chemical engineering word had stuck in my brain. And one day I Googled how much chemical engineers make, and I was like, oh, yeah, I should do that. Like that's the route I should take. And I had no plan. It was just strictly, I just saw the finance. I was like, well, I should at least try. I can always come back to chemistry. And so I applied to 2 schools. I applied to one for chemistry and got in, and I applied to one for chemical engineering, University of Minnesota, Duluth campus, and I got in and to the chemistry college, and I signed a lease with a friend from high school that I knew. I was getting ready to just straight up go down there. It was like 2 weeks before classes started, and the University of Minnesota Duluth was like, "Hey, come take chemical engineering classes." So that's how I ended up there. Those classes that I took in high school of chemistry, even though I didn't enjoy it, math, even though I didn't enjoy it, computer science, even though I just kind of similarly enjoyed it. Those were ultimately what got me where I was, not because I was good at them, but because they opened the door later on down the road to me being able to be good at them. And yeah, that's how I ended up where I am, and that's how those classes, without me knowing it, impacted my life. Well, I'll answer that first off by saying, so engineering is one of the more straightforward career paths I feel these days. Of you go to an engineering school, you get an engineering degree, you get a job as an engineer. There's generally, you don't really need a master's degree or a bachelor or a PhD to go farther into engineering. Um, the key component of you being able to take a job, though, is kind of from a legal perspective. So there's I can't remember what the acronym stands for, but the ABET accreditation for engineering schools. To work legally as an engineer, you have to graduate from an ABET accredited school. So some schools have engineering programs, and if you look at the fine details, aren't ABET accredited. So you might have a hard job time coming out of that. But generally speaking, I would say 90% of engineering schools are accredited. Um, Now, if you're like a civil engineer, for example, you will need a more specialized paperwork to be an engineer. So, like I said, the first kind of pass go check is that you finish from an ABET school. The second is if you are going to be signing off on legal engineering documents. So, let's say that you're the guy who creates a bridge, you're the civil engineer who builds a bridge. Human lives are going to be involved with you, with what you created, right? People are going to drive it and use it, and as a taxpayer, you're going to want to be safe driving across the bridge. So in that case, you're going to need a license that's called a professional engineering license, um, to be able to sign and stamp the work that you did and say that if something goes wrong, I'm the one responsible for what went wrong. If it's, the design is incorrect, um, things like that. So generally speaking, most engineers, unless you're like a civil or environmental or you're doing contracting work on your own, you don't need anything more than a bachelor's degree. If you want to open up your own contracting business or you're civil or environmental, you'll need to go on and get a professional engineering license. And part of that is, part of the reason that engineers are able to come out of college and go straight into a full-time career path is a lot of what you learn in engineering school, you probably won't ever use again. And I don't say that in like a bad way, but the reality is like if you're in a manufacturing plant, for example, and you're working, I don't need to design a pump. I need to know how the pump works intuitively, but I'm not the one going to be doing the design. I'm just going to pay someone to do the design for me who specializes in pumps. So, that kind of industry level experience of how to build things, what kind of timelines, what safety that it's going to be needed. That's all learned on the job. Going on farther into like a master's or a PhD obviously makes you a better engineer overall, but you don't really need that stuff to just come straight out of college and be successful. So that's my long answer to if you need a more specialized, skill or paperwork to be able to be an engineer. Yeah, so I'm what's called a systems engineer. A lot of people get thrown off by that because I am a chemical engineer as my training, but most of my work experience has been in maintenance. So I'm very familiar with kind of the industrial maintenance process of something breaks. How are you going to determine how serious of a need it is that needs to get fixed from like a plant perspective? Um, what kind of spare parts are you going to need to keep on hand? Something that we don't really think about for our car, but like, it'd be really nice to have a second car, right? So if one breaks, you can drive the other one, but is it actually financially worth it to have a second car, right? Or how do you determine what are critical spare parts? And then when you do the work, um, how do you, what kind of craftsman skills are you going to need, and how are you going to execute that work safely? So a lot of my experience, leads to being a systems engineer. So a systems engineer is basically, if you think about it, we have a lot of really complicated pieces of machinery that are active or passively designed to accomplish something. Okay. And so if you think about it from like a perspective that a lot of us understand of your car, well, what's the job of the system of your car? It's to drive, right? But think about all the mechanical and electrical and pneumatic systems that are working in your car to get that function provided, right? You have your brakes, you have your brake lines, you have your transmission, you have your AC, you have all these different things going on. And when you put that into like an industrial perspective, you might have entire buildings that are interacting together to provide those functions to accomplish a task. And you're going to need maintenance. You're going to need engineering perspective on how you're going to achieve those things, how you're going to make them better, more efficient, safer. That's where I come in and I do that. So that's a little bit of background of like what a systems engineering perspective would be. As far as what my day to day is, I work 410s, which I love it. I'm used to it. I used to work shift work um, prior to joining the Department of Energy. So to me, a 10-hour day isn't that bad. It's like, okay, that's just kind of how it's done. And it works out because you get 3 days off. But my day does start at 4:30 or 5 in the morning on the days I go to work. I get there at 6 or 6:30 in the morning. I check my emails. I see what happened, to my equipment while I was gone. Respond to things, and then a lot of, I would say, 50-50 split. 50% of what I do is maintaining the paperwork and all the documentation and responding to emails that's needed for the system or systems. And the other 50% is actually in the field with safety boots on, walking around, looking at stuff, and saying, okay, this is broken. How are we going to fix it? Okay, yeah, that pump's making a weird noise, but does it do that normally? A lot of planning, a lot of oversight on work. Um, I work very intimately with a lot of the craft and utility guys. They have, so as an engineer, is kind of a paradox. I build the system, I maintain it, but I don't actually turn a wrench on it. That's all the maintenance guys who do that. So I work very closely with them to understand their perspective on what needs to get fixed, and explain my perspective on how it needs to be done. And then, so yeah, it's about 50-50 of a desk job and then also walking around and getting stuff done. Um, so yeah, I work as generally 6:30 to 5 is my day, 410s, and I got my weekends off, and that's what my day to day looks like. I really enjoy working in manufacturing. Um, it feels kind of strange to say sometimes, but like I really enjoy the camaraderie that gets built inside of a plant. You know, you have operations who runs it, you have maintenance who fixes it, and engineering who's responsible for it. And so anytime that something goes wrong, you're going to be working, for me, I'm working with operations and maintenance to get things accomplished. And, it can be a chaotic and stressful environment, but I really enjoy, having these complex problems that we deal with and working together as a team of, people who may not see eye to eye on terms of like perspective. Like, I don't understand how to do a pipe fitter's job. A pipe fitter doesn't know how to do an engineering job. But I love that like I can learn from them and that we can come together and figure out how to accomplish a task. And so I really enjoy that about my job, and I do enjoy the critical thinking aspect of it as well. I am an engineer. I like building things. I like taking care of industrial equipment and solving complex problems. I think that the combination of working together as a team to solve these issues is the most rewarding part of my job for sure. Yeah, that's a great question. Where do I see myself in 5 years? I don't know. Life's so good. I try not to think that far ahead. But I would say so. Right now, I'm getting prepared to go back to graduate school. Hopefully, if that all works out, I'd like to get a master's degree in industrial engineering. So my background is in chemical, as I said. For me personally, I don't find a lot of value of going further into chemical, like learning more about thermodynamics or separation processes. I'm more interested in like the statistical side of engineering these days. So I have a process that's running, and how do I automate it so that I make my life easier? It makes it more stable. I get a better product. Also, statistically, how do I determine quality? Right, that's a very complex question from an engineering perspective. Of like, what is quality? Is it a failure per million? When you're talking about nuclear grade stuff, do you want a nuclear facility to fail 1 in a million times? You'd be surprised at how much 1 in a million happens. So that kind of perspective of like, well, what's 1 in a billion? How do we design these things like that? That's where I see myself going more in the future of the statistical implementation of engineering principles. And an industrial engineering perspective will definitely provide that. And I'm more interested in like the chaotic nature of things and how do we try and see our way through that. So I'm interested in going further into that. And as far as my career, I would like to get into some form of computational modeling of stuff. How do you model risk? What are for like your car that you drive every day? How do you determine when a car is too dangerous? How do you determine when a wheel is going to fail? How do you determine when a bearing is going to fail? I'd like to get into modeling of whether that be statistical modeling or if we just compile a bunch of chances, like what are the chances that Lauren leaves at 7 in the morning, he's 6:30, and what are the chances Lauren's drive is 30 minutes, he's 40 minutes, and we do that a bunch of times, or we have a real hard, model that we look at and determine. And I think a lot of the future of engineering too is, I know I mentioned I do some computer science. The reality of the world in general, I think these days, is that computers are only going to get more and more integrated to our lives and more powerful, right? And engineering, in my perspective, is a little bit behind the curve of embracing that. And so I think that the future is going to be manufacturing that's done where all machinery is connected by the internet and they're all communicating, and you have big statistical models running in the background determining how the process is going to run and when it's going to stop and all that stuff that's going on. And so I think that that's where I would like to have in the future, a more modeling and more computer network, internet based thing. That's where I'd like to go. So if let's just put me in your shoes. I'm still in high school. I'm maybe a junior or senior in high school, and you tell me where I would be today in 2021. I graduated in 2011, so 10 years ago. If you told me that I was doing what I was doing now and I was a successful chemical engineer, I would have said, "There's no way. There's no chance." My plan was to like play music or like go be a wind turbine technician at 18. Like that was my plan. If you can really, those are more ideas. Like there was no plan to get it accomplished. So I would say don't limit yourself on what you see today or tomorrow or even a year. Even 4 years. If you had even told me I would be living in New Mexico 2 years ago, I'd been like, "There's no way. That's not even an option." So don't limit yourself, and don't let your high school success limit yourself either. I was not a successful student in high school, and arguably even halfway through college. I finished high school with, I think, a 2.1 GPA, a 2.2. I had really no interest in going to college, and I really believe in just taking advantage of opportunities as they're presented to you. I had the chance to go to college essentially for free because my mom worked at the college at the time. And I was like, well, let's find out if I'll like college. I don't know, but this is quite an opportunity. I didn't pass that up. So ultimately, just taking advantage of opportunities that are presented got me to where I am today. And don't limit yourself by what you see right now because you don't know what's going to happen tomorrow or the next day or a year from now. And just try hard, apply yourself, enjoy your life, and if I did it, you can do it.